numbers, won't it kind of act like plugging in really big positive numbers? Let's find out. So if I plug in really, really big numbers, whether they're positive or negative, this is the only thing that matters. Okay? Even if, on this particular one, even if I were dividing by a negative number, it's still a huge negative number, right? So what am I getting close to if I divide by huge numbers? Getting close to 0. This one. Okay, the limit as x approaches infinity. On the next one. What's the only thing that matters? This, right? That's the highest power. There is still a square root in there. It doesn't go away. So essentially I have the square root of 3x over the square root of x. What is that approach as x goes to infinity? Square root of 3. Why is square root of 3? Because that 3 is under the square root, right? Just because we're going to infinity doesn't get rid of the square root. Essentially is the square root of 3x over the square root of x. So those cancel. So you're still up on the square root of 3. The next one is also tricky, very similar to that one. What do you have in the problem? Cube. Theoretically, I could go through and cube the top, cube the bottom, then I wouldn't have to worry about it. I don't really want to do that, right? Because what's the only piece that matters? The highest power. But I do need to go through and cube for the highest power piece. Why would I need to do that? 30 cubes. If I did play this out and cube it, wouldn't the first term be 27x cubed? Do I need to know that? I need to know that. So I do need to go ahead and at least cube that first piece so that I see. So these are some tricky ones that AP's trying to see if you really know what you're doing. And so then as x approaches negative infinity, I would get 27. Any questions about those? Sure. Some more. The limit as x approaches negative infinity of 95x to the 6th over x to the 5th. You notice I didn't read the rest of that. Why would I not read the rest of that? Okay. Just out of curiosity, what does 95x to the 6th divided by x to the 5th reduce to? 95x. Does everyone agree if I take this and cancel some x's, I would get 95x? Why do I need to know that? Oh, what am I going to do? Look at what would happen as I approach negative infinity. Negative really big numbers. What is 95 times a negative really big number? A negative really big number. Would you agree that this is approaching negative infinity? To know whether it was approaching positive infinity or negative infinity, I needed to kind of do that reducing to see which one it would approach. infinity of 2x minus 4. That'll do. Goes to infinity. What about if x goes to negative infinity of that same thing? Yeah. Why? True. So if I look at it graphically, right, as x approaches positive infinity, the line goes to positive infinity. As x approaches negative infinity, the line goes to negative infinity. What if I look at it numerically? 2 times a really, really big number? Really big number. 2 times a negative really big number is a negative really big number, right? Or small, depending on how you look at it. Okay? The limit as x approaches infinity of e to the x. E even e to not a very big power is a really big number, right? You get big power. The limit as x approaches infinity of x squared. Just quick question. What if that had been approaching negative infinity? It still would be positive infinity. Why? Because of the square, right? Or if you look at it graphically, both ends are going up. This next one's the hardest one of the questions. So I'm going to give you assignments.
So it's only going to be negative when it's not. It doesn't have an x.
So you'll have to think about it. You'll have to think. So if I were looking at this one, I'm going to numerically go, okay, 2 times a really big negative number. That gives me a really big negative. Now, if this had been a negative 2, that would actually be positive. Because it's negative, so negative would be positive. So I'm just going to stop and think about what would happen if I put both numbers. Why is this one true? If I look at them separately, what's the limit as x approaches infinity of x squared? What's the limit as x approaches infinity of e to the negative x? So, what if I plug in really big numbers to e to the negative power? What's a negative exponent? So which one wins, right? The 0 or the infinity? Because that's a big difference, right? One's versus infinity, one's versus 0. To see it, I need to rewrite it, because I don't know. That's another what we call indeterminate form. Infinity times 0 doesn't make sense. Just like 0 over 0. Those are things I don't know. But I can do a little rearranging. You said that e to the negative x was the same as 1 over e to the x. Would you agree that this is the same as x squared over e to the x? Which one grows faster? What's e to the x called? Like, what's that function called? Exponential growth. Right? Like, have y'all ever heard the question, would you rather have a penny every day of the year starting today, where you add a penny the next day, like 1 penny today, 2 pennies the next day, 4 pennies the next day? Or would you rather have $100? You know, everybody says they want $100. However, what's 2 to 365th power? A lot of stinking pennies. Right? Didn't work. Your calculator's not big enough. That's the
amount of pennies, or it change your dollars? You're just gonna keep doubling the pennies. It's a lot of
Like your house, flip it out. You sit there with a big pile of pennies, and you're like, how do I do this thing?
My calculator, what you would do it. So, ask you again, which one grows faster, x squared or e to the x?
E to the N.
It's actually, it's really, really big. E to the x is the fastest growing function we know. Anytime that question comes up, e to the x grows really fast. Natural log grows slow because it's the opposite of e to the x. Exponentials are in between those. I mean, not exponentials, polynomials are in between those two. If those ever come up, e to the x wins over any power of x. So if you ever have that question again, e to the x wins. So if e to the x goes faster, what is that limit? Zero. The bottom's bigger. Questions? These are some. The top one is a real AP question. The bottom ones are modifications of real AP questions. I hope the top one is encouraging to you, because that's a real AP question. The limit is n approaches infinity of 3n cubed minus 5n over n cubed minus 3n, or 2n squared plus 1. What is that limit? I will give you a minute to try it. And when you finish the top one, try it. Has everyone got an answer to number 1? What did we get? B, 3? Everyone agree? Is that encouraging to you? That's a real easy question. Especially if we only have to make it 60%, and that's all that does. So that's a good easy question.
How many questions are there?
22 plus 17 multiple choice. I'm non-calculator. That would be non-calculator. That would show up nice easy. And something like it will. Whether it's that easy or not depends on the question. These are much more challenging limit questions that could be on AP exam. I don't know if these. I could type these, and I kind of forgot where I got them. So I'm not sure if they came off a real AP exam or if I got something like that. These are much more challenging questions. Probably not real AP questions. Alright, so the limit is n approaches infinity of 4 divided by 3 plus 5 e to the negative 2n. As n approaches infinity. This one's tricky. Because it's tricky, I'm going to kind of look at it piece by piece for a minute. I'm not going to just go to one piece or another. The piece that's kind of tricky is the 5e to the negative 2n. As n goes to infinity, what does 5e to the negative 2n go to? Just, if I just pretend to press button here, and I just look at this, agree that that goes to 0? Why just, if I ignore everything else, just this piece? Why does it go to 0? Really small fraction, right? 5 over e to the 2n, and as x goes, or as n goes to infinity, that e to the 2n on the bottom makes that piece go to 0, right? If that piece goes to 0, then what does the whole thing approach? What's left? 4/3. Turns out that the 4 and the 3 were the highest powered piece. Wow. The negative exponent is lower than a 0 exponent. It's weird to think of it that way, but isn't it? Negative exponent made that go to 0. Good question. Can I just flip it and put it on top? If I wanted to do that, and it's not a bad thought, it's a little more work than just thinking it through. If you want to do that, you do have to do a common denominator to be able to flip it and put it on top. That makes sense. Because you got that 3 there, so you have to multiply it by e to the 2n on top of that. Get a common denominator, flip and multiply. What you'd end up with would you would have a 4 times e to the 2n and a 3 times e to the 2n on top of that when you finish this discussion, which is a good plan if you get stuck. Do your work, do your academic work with all this. Good questions though. Why can I not just throw it straight to the top without doing the common denominator? The addition between, right? With the only way you can just throw stuff top and bottom is if it's multiplication, right? So with that addition in between, we have to get a common denominator. Okay. Next. What happens if I plug in negative infinity into 5e to the negative 2? That piece goes to infinity. Does everyone agree? Why? Negative times a negative makes a positive, and a positive exponent on e is going to go to infinity, right? If that piece goes to infinity, what does the whole fraction do?
It's like something over infinity.
Something over infinity. These questions look almost identical, but the negative infinity versus the positive infinity change this horizontal asymptote quite a bit. 4/3 as x approaches infinity to 0 as x approaches negative. Those are some tough ones. Okay. Your homework tonight is that worksheet you have. Again, I'm going to steal a little bit of tomorrow's time like I did today. I am this time going to go ahead and pass out the next worksheet, but it will not be due tomorrow. So the one you have in your hand is the only one that's due tomorrow. What do you have? 8, 9, 10, 13 questions. So you got 13 questions on that. On the bookwork, I believe it asks the question, what is a horizontal asymptote on a couple of those? Don't forget to put y equals when you're answering a horizontal asymptote. I think you probably know that. Okay, so I want you to work this problem. Sure. You can do whatever you want. I'm not going to check your notebooks, so you can organize them however you want to. both failures for that. But with sophomores, you have to. Figure out or throw that in that field. Like that. Check it, you make sure. Like I said, sophomores need a little bit more organizational help. They're still learning how to do stuff, take notes. They still think they can just watch you teach them how to get it, you know. Oh, and those things that say two there, smart words have gotten too smart. Every year when I open this slideshow back up, it changes it to, it rounds it to 2. So the next thing we're going to look at is what happens at a vertical asymptote. We looked at horizontal asymptotes, so now the question is what happens at a vertical asymptote. Does anyone remember from Algebra 2 or Pre-Cal how to tell the difference between vertical and horizontal, or how do you find vertical asymptotes?
On bottom.
It's not a hole. When the denominator equals 0, but you don't have a hole, what would make a hole? The numerator and the numerator and the denominator equaling 0. So the numerator and the denominator come back and it cancels out, makes a hole. We've been working with holes for about 3 days, right? With 0 over 0 limits, those have all been holes. A number over 0 causes a vertical asymptote. So that's what we're going to be looking at today. When you typed in 1.9, 1.999, 1.9999, what did you get?
Bigger.
Bigger positive or bigger negative? And what do you think would happen if you put in another 9? So it appears that from the, what side is this? From the left, we are approaching negative infinity. It appears from the right, we are approaching positive infinity. And it appears from both sides so that's vertical asymptotes. The answer to a vertical asymptote limit will either be positive infinity, negative infinity, or does not exist. If we're talking about a double-sided asymptote, always does not exist. Even if both go up, the AP exam would accept infinity on that because of the formal definition of limit that I talked about, how you can't get on the other side of more of a direction than a number limit answer. Does that make sense? So, if you use substitution and you get a number over 0, non-zero number over 0, and the graph has a vertical asymptote, and the limit will either equal infinity, negative infinity, or does not exist. To determine which one, you must substitute a number from either side of the vertical asymptote to find out. So, you remember that trick we played with the absolute value? We're going to play that same trick with vertical asymptotes. So we'll talk through that. I no longer have a calculator because these would be non-calculator questions. So the first one says, find the limit as x approaches 3 of 1 over x minus 3, and then it does from the left and from the right. So if you get a number over 0, you have a vertical asymptote, you either have positive infinity, if you're left or right, hand limit negative infinity, or if you're double-sided, just does not exist. Okay, if you come to a double-sided asymptote limit question, easiest question you can come to. You plug in 3, you get 1 over 0, you say, does not exist. Done. As soon as you peg it as a vertical asymptote, I am happy with you saying that limit doesn't exist, we're done, it's vertical asymptote. However, AP may want a little more information. They may want to know what that limit is from the left and the right. And that's when they'll want you to know whether you're approaching infinity or negative infinity at that vertical asymptote. So, the limit as x approaches 3 from the left. I had a 50-50 chance on this question. Why do I have a 50-50 chance? I know the answer is either positive infinity or negative infinity, and I know that because it's a vertical asymptote. So I'm going to steal that skill I learned yesterday. You remember with the absolute value? Okay. I know it's either infinity or negative infinity. So I'm going to pick a number to the left of 3 that's really close to it. 2. And you could even envision picking 2.999999999 or whatever you wanted to pick, right? What's the only thing I need to know? The sign. Right? So if I pick 2.9999999, would you agree that I would get a negative teeny tiny number on the bottom? And if I divide by a negative teeny tiny number, I get a really big negative number. Alright, now I walked through a little more than you will have to think about. I even talked about getting teeny tiny and getting really big when you divide by a teeny tiny number. But you already know that because it's a vertical asymptote. So as soon as you know that it's a vertical asymptote, all you really have to decide is what's the sign from the left. Does that make sense? Remember, this is a non-calculator question. What about the next one? From the right. So 4. Right? 4. If you wanted to get really close, you could do 3.00001. Either way, what kind of number do you get? Positive. Do we agree? one, I get a number over 0. On a double-sided limit, what do I put down? I will tell you, there are other calculus teachers who teach this differently, and I want you to be aware of that. And I'll show you what I mean by that as we go, in case your college calculus teacher teaches it differently. Although most of the time I've seen high school teachers teach it differently. I kind of think they're wrong. Most college professors do, right? So, anyway, because the formal definition of the limit, which most college professors will go back to, that always does not exist according to that. But AP will accept either answer, so I'll show you the other answer. The limit as x approaches 0 from the left. Okay, so as I approach 0 from the left, what's a number to the left of 0? -1, -0.1 if I want to get close, right? What's a negative number squared? Positive, but there's a negative sitting out there, so what is this approaching as x approaches 0? Negative infinity. What about from the right? Also negative infinity because of that square there. So you can imagine there are teachers that will tell you that that limit equals negative infinity as well. Again, I think that's wrong. But if you ever saw that on an AP exam, they wouldn't make you choose between the two. So if B and E is not an option, then you'd pick the negative infinity option. Again, I don't think AP would do that either, but just mental note. Strange case. Are any of these single-sided? From the left or from the right? So if I look at number 1, do I have a vertical asymptote at 2? I get a number over 0, 6 over 0. So what's the answer? It does not exist. The next one, I get a number over 0. Does not exist. I will tell you this next, the one that we just did, is another one that they would have allowed you to also answer with, negative over positive. So they would have also allowed you to answer number 2 with negative infinity.
How do you know the difference between the ones that like we're doing now versus the ones that we thought we said before were 0 because there was a number over 0?
0 over a number versus a number over 0.
Yeah.
So if
my train of thought was.
that's okay.
I think I answered that question.
Okay. But it is a good question. We did some earlier that the answer to the limit was 0. That happens when the numerator is 0. And then the does not exist happens when the denominator is 0, but the numerator is a number. Remember, what do we do if we get 0 over 0? It's a whole, and I've got more work to do. So those are 3 cases I think. If I plug in -4, -4 squared is 16 plus 8 minus 8, right? So 16 on the bottom, right? Is this a vertical asymptote? It's just a normal limit. Just like the days before, don't assume it's a certain type of problem because it's on a certain worksheet. I'm going to try to throw in a couple to make you.
Well, the horizontal vertical aspect look the same unless you say.
Great question. Someone tell me how you pick out a horizontal asymptote question. What are all the limits approaching on the horizontal asymptote? Infinity. So you can pick out a horizontal asymptote question because they all say x approaches infinity or negative infinity. All of those are horizontal asymptotes. Vertical asymptotes numbers you won't know until you plug them in and hit a number on a zero. That makes sense. The bottom one, what do I get if I plug in 2? 0 on top. Okay, so that's that limit. 0. If I get 0 on top and a number on the bottom, that limit is 0. Any questions about those? Double-sided vertical asymptotes are easy. So you get a number with 0, you say it does not exist. Single-sided vertical asymptotes, you just have to think about whether the answer is positive or negative infinite. Are there any questions?